Let's address the elephant in the room. Everyone's racing to ship AI. Chatbots, agents, automations, and the demos look great. But behind the scenes, hard-coded prompts, no evals, no versioning, security as an afterthought. The elephant is AI technical debt, and it's growing faster than your model accuracy. Oh yeah, the other elephant in the room is a broken shoulder, which is what can happen if you go for a run and fail to take into account the patch of ice on the trail ahead. Yet another form of technical debt resulting from poor planning, I'll admit, but I digress. What is AI technical debt? Well, it's basically trading off speed now for costs later. Or another way to look at it is technical debt is future cost from present shortcuts. It's the interest you have to pay because you didn't make a large enough down payment up front. Those future interest payments come in the form of bugs, refactoring costs, and maintenance. This practice has been around for a while, but it's really taking off with AI, where there is such a rush to deploy something, anything, to remain competitive. Let's take a look at this situation, try to understand it better, and see what we can do to prevent it. Ready, fire, aim. Who does that? Well, that's what causes technical debt, is that kind of approach. Because basically what we're doing is we do implementation, then we do deployment, and then we go back and figure out how to plan this thing. It's opposite. It's backwards. The idea is we're going to deploy it now with imperfect results and then just fix it later in the field. So go fast and break things. Well, that's what got me this. So not always what you want to do is go fast and break things. It's sort of like trying to repair a plane when it's in the air. Yeah, you can do that, but it's a lot more difficult and it's a lot more expensive and there's a lot more risk involved. So another way to look at this is if you start off with ad hoc design, well, then you're going to end up with a more fragile system. If you don't have any architecture that you've done up front, well, then you've got no future with this thing. I mean, who would build a building and not do an architecture first? You don't just start laying down bricks and then figuring out where they're going to lie later. And then ultimately what you end up with is a monolithic system instead of one that's modular. And what we want is a modular system so I can make changes later and I have the flexibility that we need. That'll actually give me more speed in the long run. So we're making strategic decisions. And so to be fair, not all technical debt is bad. Sometimes we take it on with full awareness that this is in fact what we're doing. So we've got technical debt that's strategic, and then we've got technical debt that's reckless. Strategic technical debt, that's something that we take consciously. We know what we're doing, we know that there are some risks, and we've figured that the risks are worth it in this particular case, but we've thought it through. We've documented what we're doing. It's time-bound. We know this is not the permanent way the system is going to work, and we have plans in place already to remediate how this system is going to work when we finally get the thing out into production or after it's through its first version. So that's a way of getting out there fast. Doesn't mean we always just sit there and overthink things, but in some cases we go fast, but we have a plan to deal with it. Now, reckless technical debt is what's caused by poor discipline. We basically just didn't take the time. We didn't do the documentation, and we have no remediation plan. We have no future. All we have is a future mess headed for us. Okay, so why is this problem with technical debt particularly worse with AI? Well, let's first of all take a look at traditional software. What are the issues that we deal with here? Well, traditional software is deterministic. So you give it a certain set of inputs, you'll always get the same outputs. At least that's what we hope. And it's predictable as a result. It's testable. We can have expected results, and when we test it, we get those expected results every single time. So we've got a system that we can kind of understand, get our heads around. Technical debt in the traditional software sense comes out, though, in the form of spaghetti code. That kind of stuff where we've got go-tos and things are moving here and there and everything's interleaving, and it's just a big hard-coded mess with a lot of hard-coded assumptions. We may even have passwords and API keys and stuff like that hard-coded into, baked into the formula, in other words. So it's very inflexible, and therefore the cost of changes is very high. So we're incurring that debt in regular traditional software. And we've got missing tests. We haven't really tested some of these things out, and that's going to result in yet more debt because we're going to find out about those problems later, and they're going to be more expensive to fix later in the cycle. Now, over here on the AI side, what's AI like? Well, kind of the opposite. It's probabilistic rather than deterministic. It is non-deterministic is another way to say. In other words, there's a probability you can give it certain inputs and you won't always get, even with the same inputs, you will not necessarily always get the very same outputs. It's sensitive to the inputs that you give, but you could give the same ones and still end up with different results. It's all very context dependent as well. So what you've said before will affect what the result might be this time versus what you've done in another case with the same inputs might give a different result. It's all of these things which, you know what, it's kind of just like people. You know, we're context dependent and not always completely predictable and all that kind of stuff. One way this has been described is change anything changes everything. So that's kind of how we look at AI. And ultimately what this means is because AI moves really fast, then as it moves fast, then debt compounds even faster. Okay, so let's take a look and see what are the different forms of AI technical debt and how might they be manifested in our particular system. Well, we're going to look at 4 different aspects of this. The first we're going to start off with is data, because there is no AI without data. We use data to train and tune our systems, and all of the decisions that it comes out with are based on data. So that means we're subject to garbage in equals garbage out. With an AI system, the garbage out can actually be amplified. So we've got to make sure that the data that we're feeding in is good. We've vetted the sources and we know that they're trustworthy and that they're correct. We need to make sure that we don't have bias in the system. If we fed it too much of one kind of data and not enough of the full spectrum, then it's only going to be accurate on that particular segment. And we need it not to be biased. We want it to give good results across all different data types, or we end up missing something important. We need to check for drift. We need to make sure that even though this thing was trained on good data to begin with, that it hasn't changed over time because, it may have seen too much of one type of thing. And then we may need to make sure that, that we haven't had a case of poisoning. We were in such a rush to get this thing out that the system just got deployed and somebody actually put some stuff into the data intentionally that's messing all of this up. We may also want to protect data by anonymizing it so that and that's the kind of thing that we tend to overlook if we're in a hurry. So we need to take advantage of anonymization services so that our model doesn't leak important information like personally identifiable information or confidential information from the organization. The next type of AI debt is with the model itself. So the model, we need to make sure if you're incurring technical debt, one way it happens is from no version control. You just bring in a model and deploy it and go. We're not clear necessarily when we're going to make an update to the model. We're not clear when we do what the plan is for doing that. We're not clear if there's any way to do evaluation of the model itself. We need to have metrics where we're seeing and judging against model drift and things like that. And then we also need to have the ability to do rollback. And in an AI technical debt situation, we might not have had any of those capabilities, no ability to roll back. So now, if we find that there's an error once this thing is deployed, it's going to cost us a lot to pull this thing back in. I need to do penetration testing against this model. Look at all the different attack types that could be and figure out if my model is vulnerable to those things. If I don't, it's yet more technical debt that occurs. Another class of technical debt is prompt technical debt. The prompt is what the user is putting into the system, if we're talking about a chatbot, for instance. So we may have an undocumented system prompt. The system prompt's the thing that you feed into the large language model, telling it what its context is. And if that's not documented, we don't know what kind of a system we're going to end up with in the long run. So we need to make sure that we've thought through those kinds of things. We might have no validation of the inputs coming in. The prompts that are coming in, this can be not just input from the user, but it could be input into the system and change the behavior of the system. It may override the prompt, the system prompt, and that's what we call a prompt injection. So we need to not incur those kinds of situations. Prompt injection is something that absolutely result from going too fast and not checking for all the cases. We could result in data leakage. As I mentioned before, if we're not checking the information that went into the model, well, then we could have the model with sensitive information. At minimum, when we're having information exfiltrating, coming out of this thing as a prompt response, I want to make sure that I'm not leaking sensitive data. So that means, and also that if I've not put any guardrails in place, well, then I'm going to incur more technical debt. That could come in the form of lawsuits and things like that. So one of the things that helps here is putting an AI gateway between the user and the AI model and have it check the inputs that are coming in, block the things that look like prompt injections or look like they might be getting around the guardrails, and also redact the information that's coming out that might be of a sensitive nature. And then our last category of technical debt is organizational technical debt. In this case, we have basically what the organization sees from all of this perspective. We're asking questions. If we didn't decide who owns this thing, we didn't decide what is the governance policy for this thing. If I don't have a policy in place, then I don't know if I'm doing the right thing or not. And I'm going to figure it out later, and it's going to cost more later. So it's much better if we have also done red teaming, basically testing the system out and putting it through its paces. If I don't plan properly, the system could have latency. It could be slow to respond, and it's not going to, we did it in the prototype, we moved fast, it all looked great, then we put it in the field, and it didn't work great because all of a sudden everybody starts hitting it, and it doesn't have the capacity. It could end up costing us more if we didn't plan for this. All of these things that I've talked about, there's a cost associated with remedying every one of them, and another one is scalability. We've got to make sure that the system will keep up with the demand that's out there. If we don't do all of these things, they incur technical debt, and in the end, we end up with an AI that we don't trust. Ready, fire, aim. Okay, we can all agree that's not the way to do it. We need to be able to do ready, aim, fire. So what does that look like in terms of an IT project, and in particular an AI project? Well, it's the basics we need to remember. We don't get to skip just because it's AI. We start with requirements. We move then into architecture. Then we go to implementation. Don't start with that. Then we move into testing it. Then we deploy it. Then we evaluate what we've done. And then we feed all of that back into our requirements. Nothing about this changes. That's still true, and it still applies to AI projects. If you think about it this way, AI technical debt is what results from speed minus discipline equals this massive compounding interest on the debt. And what we want to do is burn down that debt. In other words, if you don't put enough money down on that home loan, you're going to be paying on interest forever, and the house is going to cost way more. Another way to think of it, if you don't know where you're going, any road will take you there. Because if you don't, there's no telling where you're going to end up, and worse still, there's no telling how much you're going to owe for the experience.